juice, and I kind of wanted to see what it does. Are y'all down for that?
Yeah.
Y'all are pretty down. So, alrighty, let's see what happens when we add different solutions to this liquid. But before we begin, gotta be safe. Safety first, always. Let's toss on some safety goggles. Okie dokie. What do y'all think's gonna happen when I add this clear solution to this purple red cabbage juice?
It's gonna get watery.
That's a pretty good guess. I mean, we're adding more liquid to it, so it might become more dilute. Anyone else? No? Alrighty, let's get a countdown. 3, 2, 1. Whoa, Nelly. Can you see it? What happened?
It's kind of pink.
Got a little bit lighter.
Turned kind of pink, turned a little bit lighter. Kind of hold up to the light. And if we can compare the two, this one's definitely looking a little more red than this one. So that's pretty cool. Let's do it again. What do you think is going to happen when I add this other clear solution to this one?
The same thing will happen?
That's a pretty good guess. I mean, adding another clear solution to it, might as well do the same thing, right? All right, another countdown. Let's do this.
3,
2, 1. Whoa, Nelly, this one's a little more noticeable. What happened here?
It's blue.
Yes, it is a very beautiful blue color. So today we are going to be discussing solutions and how they kind of change. So I think I'm going to turn it over to Lauren.
While Alan's passing out some materials, let's go over what just happened here. Why did one beaker change one color and the other changed another?
Chemical reaction took place.
Correct, a chemical reaction took place. Now, Alan is passing out this worksheet, which is the pH scale. There was a chemical reaction. The pH of the cabbage juice changed when each solution was added. The color change was caused because cabbage juice is known as an indicator. Now, an indicator is a substance that changes color depending on the properties of a solution. So let's fill in this definition right here. A substance that changes color depending on the properties of a solution. Now, we can use this color change to indicate a certain property of a solution. Notice that the P is lowercase and the H is uppercase. That's how we always write pH. pH is a measure of how basic or acidic a solution is. So let's fill that out on our vocabulary sheet. pH is a measure of how acidic or basic a solution is. What does pH measure again?
How acidic or basic a solution is.
Correct. pH is a measure of how acidic or basic it is. Scientists need to know the pH of solutions in order to figure out whether or not they are dangerous. Changes in pH can be dangerous. For example, in the environment, we use pH as an indicator of pollution. Even doctors run tests on the pH of blood to see if it's more acidic than normal, which can cause a lot of health problems if it is. How many of you like to swim or have ever been swimming?
Ooh, yes, me.
Yeah, everyone likes to swim, right? It can be a lot of fun. Well, pH is very important for swimming too. We have to check the pH of swimming pools on a regular basis. If not, your eyes may start to burn when you get in the pool, and we don't want that, right? No, we don't. We want to have fun in the pool, so that's why we have to keep track of the pH. Now, looking at your worksheet, what is at the bottom of the pH scale?
0.
Correct. And what's at the top?
14.
What about the middle? What's exactly in the middle?
7.
7. Correct. Now, acidic solutions are said to be pH values of 0 and 6. So any solution that has a pH between 0 and 6 is considered acidic. Any solution that has a pH between 6 and 8 is considered neutral. any solution that has a pH between 8 and 14, we call those solutions basic. So now I have a question of the day that I want you guys to answer. At what pH does milk curdle? Before we do anything, I need to go over some important safety instructions with you. We're going to read these together. So the first one, I need someone, can you read number 1 for me, please?
Wear goggles at all times.
Correct, we need to wear goggles at all times. 2, can you please read number 2 for me?
Do not taste, touch, or smell the substances.
Correct. Some of the substances we're going to be using are ammonia, vinegar, and lemon juice, and they're known to irritate eyes. Ammonia can even irritate skin. So please practice safety and don't taste, touch, or smell these things. Number 3.
Wash hands after the experiment.
Correct. Be sure to wash your hands after the experiment and use hand soap. What did we say the pH was hand soap again?
10.
10, correct. So we're going to use hand soap to wash our hands because we don't want any of the stuff to stick if it spills or anything. Also, regarding spills, what's our 4th instruction?
Notify a teacher of spills immediately.
Correct. Please don't hesitate to tell us if a spill has occurred. We need to make sure to keep the classroom safe and clean it up before anyone gets hurt. Now, Alan is going to go ahead and pass around the goggles. Goggles are very important for our experiment today. You must wear your goggles at all times. If I see you without your goggles on, you're going to lose your privilege to participate in this experiment, and you're going to have to sit out. You don't want to sit out, right? You want to have fun. So please be sure to wear your goggles to keep safety. We're also going to be handing out paper towels so that if anything happens, we can clean that up. And also, we're going to pass out some job cards. We're going to make sure that everyone at your table gets a different job card. We're going to use these to do the experiments in our after-school club. If you don't get a card that you don't want, don't worry about it. The next week, you may get a different one that you want. Everyone will have a chance to do a different job. Now, if you have a yellow card, raise your hand. You are the time and safety manager. It's your job to make sure that everyone follows the safety instructions and make sure that you stay on task. If you have an orange card, raise your hand. Can you see the orange cards? All right, you are the materials manager and technician. Your job is to gather and return all materials that you use and make sure that everyone uses the materials for what they're supposed to be used for and not as toys. As we said before, we gotta keep safe. If you have one of these lime green cards, raise your hand. All right, you guys are the recorder and the reporter. It's your job to record all the data you collect for this experiment, and report your group's findings to the class. Lastly, our blue cards. Who has a blue card? Your job, you guys are the principal investigator. Your job is to make sure everyone is involved and has a turn, and that you complete all parts of the activity. All right, I've got a mystery solution here, and I need you guys to help me figure out what we're testing. Now, how do you think we can test the mystery solution's pH?
Cabbage juice.
All right, yeah, we used the cabbage juice earlier, and the cabbage juice showed us the difference in pHs from the chemical reaction. But cabbage juice only changes color when an acidic or basic solution is added to it. When we want to know the exact pH of the solution, whether it's 0, 14, or 7, or anything in between, we can use pH indicator strips. So Alan's going to pass out these pH indicator strips to all of you, and let me show you how they're used. To test the solution's pH, you need to dip a pH indicator strip all the way into the solution. As you can see, there's 4 little squares on it, and you make sure that it is completely immersed in the solution. So we have our mystery solution, and make sure to dip your pH strip completely in and hold it in there for 5 seconds. 1, 2, 3, 4, 5. Then you take it out, and you're going to use a key, and that's provided with your strips, to figure out what the pH of the solution is. You're going to hold up your strip to this key and see what numbers it matches up to, which colors it looks most like. Now you're going to be working in pairs for this activity. And once you've identified the pH of the mystery solution, you need to write your results up on the board. So we're going to go ahead and pass out the mystery solution to everyone, and everyone can work in pairs and use their pH strips to test it. All right, excellent job measuring the pH of the mystery solution. The mystery solution is actually water. You get straight from the sink. It's just basic water. Water is an example of a neutral solution. So we can write that down on our worksheet, that water is a neutral solution. Now, Alan's going to go around and pass out a rack with 4 test tube solutions. We need to identify the pH of these solutions. We have 4 solutions here. We have vinegar, we have ammonia, baking soda, and lemon juice. You're going to need to test the pH of all of these solutions using your pH strips. Now you're going to also work with your group of 4, and you'll work in pairs during this experiment just as you did before. But also, once you've found all the pH of the solutions, you're going to share your results with the rest of the table. All right, everyone, let's fill this in on our pH scale. What pH did you find for vinegar? What did you find out vinegar was?
3.
3, it's around 2 or 3, right? So we're going to go ahead and write that down, that vinegar is around 2 or 3. What about ammonia? What did we find out ammonia was?
Like 11, 12.
11 or 12? All right, so we'll write down ammonia on our pH scale. What about baking soda?
10.
10. Yeah, everyone got 10s. All right, we'll go ahead and write baking soda as 10. And last but not least, lemon juice. What did you find as the pH of lemon juice?
Like 1 or 2.
1 or 2, right? It's very acidic, so we're going to write that down for lemon juice. Now, remember the test tube of milk I passed around?
Yes.
What are we trying to solve?
What pH is milk curdle?
Correct. Our question of the day was at what pH does milk curdle? Now, when milk curdles, you should be able to see it stick to the side of the test tube, correct? What were the things we identified of milk? How did it look when it was curdled?
Clumpy.
Clumpy?
Sticky.
Sticky? All right, it didn't look like normal milk. Now, remember, I have these test tubes up here for comparison. You're going to have milk in one and your curdle in the other. Now, in pairs, you'll perform an experiment to test and reach a conclusion regarding the pH of the milk and see at what pH does milk curdle. Before you begin, you need to write a detailed procedure of the steps you plan to take to answer the question. Alan's going to go ahead and pass out these experimental design worksheets. Now, we need to be sure to use proper scientific terminology. For example, these are called pipettes. Some people like to call them droppers, but the proper name for these are pipettes. So you're going to go through, and our problem is at what pH does milk curdle, and you're going to think of an hypothesis. What do you think the pH is going to be? Write down a guess of what you think the pH is that milk curdles. You're also going to write down the materials. What will you use for this experiment? What type of materials are we going to be needing? And also, we have a procedure. What is a procedure?
The steps you'll take to complete something.
Correct. The procedure is detailed, and it's all the steps you're going to be using for your experiment. Now, once you have a detailed procedure, raise your hand, and we're going to check it before giving you the materials you'll need. You must also have your data table ready. Now, what does your group need to write before you get any milk?
Materials needed, procedure, and have our data table ready.
Correct. We need your sheet prepared. You've got to make sure everything's planned out before you proceed with your experiment. We're going to pass out another worksheet that says what to think about when you're writing your experiment. So you can read over that and see what you'll need for this experiment.
Alrighty team, let's discuss our results. So what was the pH of the milk before we added any solution to it?
Around 6.5.
Yeah, around 6.5. So where does that put milk on our pH scale? Well, 6.5, is it an acid, a base, or is it neutral?
It's neutral.
Exactly. It falls between 8 and 6, so we can consider milk neutral. So at what pH did y'all find that the milk curdled?
Like 4.6.
Okay. So around right here. .6 milk curdled. So is that within the acidic or basic range?
Acids.
Yes, it's within the acid range. So which of our solutions then made the milk curdle?
The acidic ones, the lemon juice or the vinegar.
Yes, exactly, the lemon juice or the vinegar. And so that's an important finding. It didn't matter which acidic solution we used. All that mattered was that the acidic solution added was strong enough to make a new solution that went below a pH of 4.6. Whenever milk goes bad, what do people say? What do you say about the taste?
Sour and it smells.
Yeah, milk goes sour. So what does that tell you about the properties of an acidic solution?
Are they sour too?
Yeah, you could consider it as acid sour. That's just an interesting aside. I don't recommend you go around tasting milk when it goes bad, or acids that could get you sick or hurt. Remember, science food, don't drink it. What other acidic solutions have we worked with today that are sour?
Lemon juice.
Bingo! Lemon juice and other citrus fruits have citric acid in them and tend to have a little sour taste, puckers up your mouth. Because milk curdled at 4.6, we can conclude that an acidic environment was necessary. Once you found the milk curdled, did you stop or did you continue testing the other solutions?
Well, I mean, we already found our answer, so we don't have to continue, right?
Well, why might it be important to continue even though you already found an answer?
Well, maybe we were wrong the first time.
Yeah, you could have been wrong, or maybe there's other results you get, like maybe basic solutions could make the milk curdle. We don't know. As scientists, it's important to continue collecting data even if you found what you're looking for, so you have more data and draw broader conclusions from your experiment. Alright, so let's just continue our discussion about spoiled milk real quick like. Within milk, there are many proteins as well as lactic acid. Over time, lactic acid builds up and the pH begins to change until the proteins lose their shape and clump on together, giving the clumpy like stuff we see in curdled milk. So, what observations can you make about these two bags of straws that represent milk?
One of them has really bent up straws and they're really just messed up, and the other one they're straight.
Yeah, exactly. So, with this bent straws are clumped up and the other straws are lying flat. So which bag models how the proteins in the milk look before we added lemon juice or vinegar?
The laying down the straight ones because it looks smooth like the milk.
Yeah, so when we try and pull one out, what do you think will happen?
Just pull one out.
Yeah, one comes out, the others aren't really affected. They all run past each other like a liquid. So when it went bad, it looks like this. So if the unclumped proteins pull out easily and don't really pull out any others, what do you think the clumped up bag is going to do?
They're going to come out all together. They're sticking together.
Let's try that. Yep, they're all in there. So one straw might be attached to another straw. If I pull one out, all these clumped up proteins are tangled around each other in knots. I'll pull out several more, which is why milk curdles like that. So what effect does the shape have on the volume that the straws take up? Like, look at the bags. What do you notice?
The bent ones take up a lot of room.
Yeah, the bent ones take up more space. When it goes bad, the proteins form clumps, take up more space, gives it a little more area. So thanks to your experiment, we were able to demonstrate that milk curdles at an acidic pH, and now you can tell your parents and friends the science behind why milk goes bad, and you'll seem super smart.
Alright, now that you've designed and completed an experiment and learned the why behind milk curdling, it's time to reflect and analyze your work once again. So let's go over the conclusion questions on your experimental design worksheet. So what was your conclusion? What was your answer to the question of the day? First of all, what was our question of the day?
At what pH does milk curdle?
Correct, so what was the pH that milk curdled?
4.6.
Correct, it curdled at 4.6. So what could we do again? What would you want to try next? What are some things you'd like to try with pH? You can test other solutions.
Yeah.
There's a lot of different things you can do with it. And what about revisions to the experimental design you came up with? Those are things you can talk about with your group and discuss what are some changes you make. Now, you guys did fantastic, and it's time to do our show it off worksheet, our review. Everyone's going to get one of these, and you're going to work on it on your own, and then we'll go through the questions together.